The year is 2099. Humans have been traveling in space for 150 years. Every part of our solar system has been explored. Missions to the nearest stars are on their way. But space travel has proved hazardous for human beings. And death lurks in the hostile environments of the planets and their moons. And so, through human ingenuity, a new breed of space explorer has been perfected. These are the SIMs, 5 super intelligent machines capable of operating in the most extreme and threatening conditions. Earthlink, the mighty spaceship which carries them across the void. On board is Lander, the transfer vehicle and sanctuary while on a mission. Inside are Legs, who tackles the most dangerous terrain. Wheels, the roving scientific detective. And Hover, the rescuer and scout. This team of trailblazers acts as agents for the human race, adventuring far into the solar system and beyond. Their destination, space. In the year 2072, the SIMs explored the giant planet Jupiter. 5 times further from the Sun than Earth, Jupiter dominates the solar system, with its great bulk weighing in at 300 times the mass of Earth and 1,000 times the volume. Jupiter is a gas giant, a dynamic world of swirling clouds. Its great red spot, a hurricane larger than Earth, has been blowing for at least 3 centuries. Hover will plunge into these spiraling clouds to measure temperatures and wind speeds.
I'm not sure about parachuting down into that maelstrom.
It would be a one-way trip for you, Legs. Only my new megajets will allow me to take the battering from the gales of the red spot.
My drive across one of Jupiter's smallest moons will seem tame by comparison.
Rolling out now. We have clearance to commence mission to Jupiter and the red spot.
400 seconds on 90% thrust. V1, V2, rotate. Off to deep space. Jupiter, here we come.
Legs, program 5 Earth orbits to take us to the transfer point for space station acquisition. That will give us time to look at Earth's atmosphere. It's so calm compared with Jupiter's. See that hurricane building up over the Pacific? Its wind speeds are now reading over 100 miles an hour. That could cause enormous damage.
A mere breeze compared with the worst of Jupiter's winds. But I could still fly safely with my megajets, even if the winds were 10 times stronger.
Lightning is often part of the storm structure on Earth. Huge electrical currents arcing from clouds to the ground. But Jupiter's electrical storms are many times more intense. A lightning strike from one of those could knock out our main computers.
Jupiter is a huge ball of gas spinning every 10 hours. To human eyes, the topmost cloud layers display pastel shades of cream, brown, and orange. They encircle the planet in belts of light and a dark color. Enhanced color imaging reveals a turbulence within those belts. The great red spot is like a whirlpool in the cloud tops. Wider than Earth, it takes 7 days to rotate. whip round by winds of 250 miles an hour. Through a blue filter, we see some of the smaller light spots caught up in the flow, and with exaggerated colors, the chaotic tumult around the great red spot. This is the tempestuous planet the SIMs are preparing to visit. The engineering section of the space station will modify them for the brutal conditions on Jupiter. They will all need protection from the intense radiation and violent electrical strikes. Hover's flight to the red spot will mean exposure to a further danger, the terrible winds which rage across Jupiter's cloud layer. Fitted with high-powered megajets, he will battle against those superstorms and a gravity field which will be waiting to suck him into oblivion.
Docking ports aligned. Stand by for modification interface. Anything can happen when lightning strikes. We're being given extra shielding for our vital systems and heavy-duty backup on all computers.
I've got a super speed flywheel for this trip instead of electric motors. As long as it spins, I keep going.
A flywheel sounds positively primitive. I have the new transonic booster megajets for the first time. Jupiter's 300-mile-an-hour gales, no problem.
Well, I will have the robot arm instead of the drill.
Modification complete. Undocking now.
Setting course for beyond Mars and then through the asteroid belt to Jupiter. Plutonium energy source active. Ion drive at 0.02 G for 20 days.
Mighty Jupiter is 500 million miles from the Sun, but it'll take Earthlink only 8 months to fly there. On the way, the SIMs must pass safely through the asteroid belt, where smaller fragments are uncharted. These pose a constant danger.
Lots of improvements have been made to my avoidance radar since the last time we came through.
And I've got improved logic circuits for navigation through the collision zone.
Because Jupiter has no solid surface, we are to land on Amalthea, a small moon 100 miles across. It's just like an asteroid located 70,000 miles from Jupiter's cloud tops.
Even that is off limits to humans. Radiation, poisonous clouds, and fearsome electric storms mean they send us instead, 100 years after their first spacecraft breezed past.
You mean the two Pioneer missions, numbers 10 and 11?
Pioneer 10 was launched in March 1972 on a 21-month journey to Jupiter. Pioneer 11 followed 13 months later and also went on to visit Saturn. Pioneer 10 passed 82,000 miles from Jupiter. It sent back to Earth the first ever close-up images of the giant planet. Still traveling, it is now headed out beyond the solar system towards the nearest stars.
Then after the Pioneers, it was the Voyagers, launched in 1977.
Thousands of miles beneath the clouds pictured by the Voyagers, pressure is millions of times higher than on Earth. Hydrogen, the lightest gas, is crushed so much it's like a metal. And far above the clouds, Voyager 1 discovered a faint ring made of dust blasted off some of Jupiter's small moons when meteoroids strike them.
Amalthea, where we're going, is in the outer part of the ring system.
In the 1990s, Galileo followed the pioneers and Voyagers. But unlike them, Galileo went into orbit around Jupiter and returned images for several years. It also released a probe, which continued the journey on its own until it plunged into Jupiter's clouds in 1995. Buffeted by winds of 200 miles an hour, it descended 1,000 miles before being crushed by the pressure.
What a way to go!
You're right, Legs. We may also see the intense electrical activity in Jupiter's atmosphere.
Around Jupiter's poles, bright auroras glow. Elsewhere on the planet, like here around the Great Red Spot, bolts of lightning pierce the clouds.
We're well past the orbit of Mars and starting to encounter the first stray rocks of the asteroid belt. Interesting objects can be lurking anywhere out here.
Deploying telescope for asteroid search and analysis.
I'll check the asteroid database against our position and warn you if there are any we should be on the lookout for.
This one could be of interest. Infrared response shows signs of exotic ices.
Exotic ices. So what's this month's flavor, Legs?
Methane chunks in ammonia slush and organic molecules. Close in for a closer view and engage spectrometer.
Negative to that. We have a problem. Our radar transmitter beam has failed. We now have no advance warning of any rogue asteroids.
Couldn't happen in a worse place. This is the densest part of the asteroid belt, and too dangerous for hover to make an EVA.
The main danger is those small rocks made by collisions between the asteroids. Here's one. Telescope on forward scan, Legs. Extreme vigilance, everyone.
Here's another fragment. Trajectory harmless.
Take evasive action all the same. Debris swarm up ahead, Legs.
I'm on it, Earthlink. The fragments are quite spread out, but I'm taking no chances. Set Z vector 5 degrees negative. X to 12 positive. Now Z to 15 positive.
Good piloting, Legs. Keep alert.
With the asteroid belt safely crossed and now far behind them, the SIMs approach Jupiter.
Beautiful, but deadly. To reach Amalthea, we must avoid the radiation loop linking Io to Jupiter. Magnetometer online. I'll fly a trajectory for minimum exposure.
Electron density soaring. Radiation close to maximum tolerance.
Reset Y vector to +6.
With the radar defunct, I'll remain at high altitude. Lander, prepare to disembark for Almathea.
Standing by.
Optimum position reached. Launching now.
Only hover will get nearer to Jupiter than this. The orange color is sulfur dust, spewed out of Io's volcanoes. We are going for a landing.
My flywheel engine is working beautifully.
Just 1% of the radiation I'm detecting would kill a human.
Gravity here is 400 times weaker than on Earth.
That's dangerously low for us. Let's get the microgravity safety kits working. Ballistic anchoring secure.
Locking down to Amalthea right away.
I feel as light as a feather. Let's see what happens when you drop a rock.
I will lift it 3 feet. Here goes. On Earth, it would drop in half a second.
It's going slower than a feather. 12, 13, 14, 15 seconds on Amalthea.
Time for big science. Legs, we need plenty of samples. Our mission is to find materials that will allow scientists to put together the past history of Amalthea.
Subsurface rock and ice will be needed for that, Wheels. The stuff lying on top here might just be recent debris from comets. Come on, let's blast down for some older samples.
That's rock, not ice you're bringing up.
Exactly. That could mean Amalthea is a fragment from the breakup of a much larger moon long ago.
I've loaded that sample. Let's pull up anchor and get to another location.
And so Legs and Wheels began several days of sampling the ices and rocks of Amalthea, undaunted by the vast looming bulk of Jupiter. But even more hazardous was Hover's task, an excursion to the red spot.
You two have it so easy it must be boring. I'm off to the red spot. Now that is exciting. On this mission, I'm finding the temperatures and wind speeds on the borders of the red spot. I'll be going about 1,000 miles down. Wind speed 300 miles an hour. Temperature rising, and so is the pressure. Composition includes methane, hydrogen sulfide, and ammonia. The high clouds are ammonia crystals. I've reached 10 times the pressure on Earth. Lots of organics here. Megajets running flat out to stabilize against the gale force winds. Temperature and pressure readings going nicely. How's your holiday on Amalthea going?
After miles and miles of exploring, my flywheel has ground to a halt.
That won't do. We need the samples. Lander, can you drive to our position?
What? Wheel stuck again? On the way. Now, let's see what we can do.
Lander, let's restart the flywheel electrically.
Connecting up the power supply.
Okay, go live.
Yes, it's turning. Spin me up, Lander.
I'm the one who's spinning. The megajets are unbalanced and I'm whirling out of control. I'm starting back up, despite these gyrations. Board quickly. Hover's in a spin. We'll try a rescue, but it won't be easy. All hatches closed. Stand by for takeoff. I have your coordinates, Hover. I'll station myself as close as possible. You are in range, Lander. I should reach you very soon. But how are we going to stop the spin? Oh! That last squall almost drenched me to pieces, but it did slow the spinning. I copy. That's a spin I can synchronize with. I'll turn over. Vertical axis aligned with hatch. Okay, now I'll match your spin rate. What a stately dance, Hover. Thank you, partner. Alignment confirmed. I'm coming aboard. Earthlink is moving in on a rendezvous course. We'll be docking within the hour.
Congratulations, Lander. Maybe we should have a ballet score written for you and Hover.
And so the SIMs had survived another great challenge. Hover's rescue was crucial. The wealth of data on the hurricanes of Jupiter was highly significant, and the rocks of Amalthea did indeed hint at an origin born of a cosmic collision.